This next part of the demonstration, we're going to be creating a synchronous sheet metal part. So we want to change the configuration to sheet metal pulley cover. Just zoom into this area. And if we go to the Pathfinder, then you want to expand the only active subassembly. And the very first part that's active is 00333.psm. This is the file that we're going to in-place activate into. Make sure that you have your show hide up there on the quick access toolbar. And here we're just going to create a rectangle based on this plane. Just pick up this endpoint. And what I like to do here is actually type in the value 190, 200, and 0 to specify the size of that sketch. And then we'll use that region to actually build the sheet metal part. So how did it get the thickness? You want to go up and show that you go to the Properties, Material Table. This is where you specify the type of material that you're going to be using. Also, the thickness is based on the gauge, and in this case you want to change it to 14 gauge. Apply that to the model, and you can see the thickness changed. The next step then is to select these three edges. You want to hit the space bar after selecting the first one, so you get your plus minus. Grab the small arrow to build flanges and come down to this endpoint on this bracket on the side. You can see that we have the bolt sticking through the top here where the pulley is. So we're just going to come up here and sketch a circle. Size isn't important. Just come up here and hit the dimple using the default values to dimple that material up to create some clearance. Turn the background off, because next thing I want to show is how we can control the size of this sheet metal part. So you want to add a dimension to the outside but also to the inside. And in most systems you can use the outside dimension to determine the size of the sheet metal part, but oftentimes what's really important is the inside. So rather than have to take the outside and subtract the 2 times the material thickness to get the inside dimension, I can go directly to that dimension and specify the size, and the part will adjust appropriately. Now you want to rotate the model around and turn on the background again, and you can see that we have obviously some interference. I've went ahead and put the jog command on the quick access toolbar. So to get that, we just draw a line on the side of the part about here above the belt. Then you can go up to the jog command, and you just want to jog this over. Now notice I moved my cursor off of the deck as fast as possible because I don't want to pick up any key points of the deck. So I have it out here in the white space. I want to come out about 25. You can key in 25 if you want, or you can just click. Next thing that I want to do is rotate this face. Now before I rotate it, I know that I need to turn off coplanar in order to get this to rotate. So just turn that off ahead of time before I ever start the rotate, and that way it always works and I don't have to show any type of failures. And you want to rotate that out around 40 degrees. Rotate the model around. You can see that we have a gap here in the back that we need to close up. I'm just going to grab this edge. I'm going to pull it in. Don't go real far with it, but what we want to show here is that we want to relate this, and we want to make it a coincident with this back edge. Accept that. Next thing we want to do is close this gap up a little bit. So if you pick this edge, a nice way to do this is to hold the shift key and click on the primary axis, and you just want to specify a 1 millimeter gap here. Accept that, and then click the arrow again and then pick up this endpoint, and that way it specifies a 1 millimeter gap between those two edges. If we back up a little bit, we'll go ahead and grab these two faces, these two edges, and drag them off to create 2 more flanges. I'm going to come over here and pick up this endpoint. And again, we want this back edge to be nice and coplanar. So I'm going to pick up this thickness face this time, and I'm going to relate it also to be coincident with this face. Now if we move over to the other side, you can see that the bolt is actually out a ways. I want to show how I can angle this face. But before I do that, I really need to take this flange. I want to specify a particular width of 40. I'm going to hit the tab because I also want to lock that so it can't change. So as I rotate this face, it will maintain that 40 millimeter dimension. And to do this particular move, you need to turn off orthogonal, turn off symmetry, and turn on coplanar. And then as you drag this, you can see that it will move where we want it to go. And you can specify maybe a 20-degree angle. Let's rotate this around. Maybe I want to make a few other modifications to my part. We also want to show we've done a lot of clicking and dragging. We want to show that we can also control this with dimensions. So I'm going to add a dimension. I'm going to pick that dimension. Before I start making any kind of changes, I'm going to turn off coplanar and turn orthogonal on. And then I'm just going to drop this down to where I actually get some interference again with that top bolt, and then switch to the modify the other side so that you can show that you can control either side of that dimension and push either side. So you want to make this about 40 millimeters. You can see that this back edge now is above that, so you can pick this and just drag it down to a key point if you want. You can pick up any of these edges so that it's flush. You see I have some interference with my pulley here, so I'm going to add an angle onto this edge also. I'm just going to pull this, and again the angle is not really important, but about 25 or 26 degrees is good. And maybe even grab this edge, move the steering wheel to the corner, and show how you can push this back in this direction. It looks pretty good from that angle, but then when you come to the top, you can see you have this big corner that maybe you don't necessarily want. So what I like to show here is I want to draw a line on this face. Now I'm using the N on the keyboard to get the green edge along the right side there and go ahead and lock. And then I'm just going to sketch a profile. You need to make this a closed profile, which will give you the regions that you need to go ahead and select. Using the symmetry option, you're going to create a cut in both directions, and you want to cut clear through the part. And then you just right click to accept. So you should have something that looks like this. The next step that we want to show then is how we can modify this dimple. I'm going to select the dimple. I'm going to change the value, the offset value first. I'm going to make it 8 millimeters so that we make sure that we clear that bolt again. But I also want to completely edit the profile from what it is right now. And how I'm going to do that is select the line. I'm just going to pick over here on the side so that I can drag around and get a vertical tangent. Come over to this edge and then come horizontally, and then just kind of eyeball these last couple lines, because then what you can do is go back and add a parallel relationship between these edges. And then you want to trim away that part of the circle, and so there we've modified the shape, and when you click the green check mark, it will change the shape of the dimple. Just hit escape to get out. And you may want to add a few more features like holes for the bolts. Use the include, and you want to pick up those two circles, and then you maybe just create a hole of let's say 10 millimeters, and we'll use the center of those sketches to locate the hole. We could also add some corner breaks to this. So we use the break corner command, and we'll make this 10 10mm rounds on all of these corners here. Hide all the sketches. And now, of course, the thing to show is how we can create the flat pattern. So you want to go to your tools, flat pattern, and very quickly show creating that flat pattern. It gives you the overall size of the flat. And then you can go back to the design body, and the next thing you want to show is bend table. And you want to show how you can control the bends. Let me resize this. You have bend 8 maybe should be the first bend, so you can move it all the way to the top, and you can see as you move it up that balloon changes. And you can change these to however you want for the operation, the bend operation. Click OK. And now what we want to do is create a drawing. So to create the drawing, just like we've done before, you want to come up here, New, Create Drawing, and this time you're going to browse again to a quick sheet, and this one is called Sheet Metal Draft. And this one we don't have a difference between first and third angle because we're not pulling any views, so you just go ahead and use that draft template. This places the flat and also an isometric view. At this point you can show actually placing the bend table onto the drawing view. If you want to go into the options, you can show adding a title if you want, bend callouts. You can see that we're actually calling out the bend sequence in this particular case, and that we're going to place the bend callout in line with the center lines. And so if we place that, you can see it adds the bend number, sequence number, from the table. At this point you could also show some different types of dimensioning, maybe show coordinate dimensioning, where you can select a base 0, and then as you pick each one of these you can drag and get the correct value. You also can show creating a jog by starting to drag up here, hold the Alt and click, and that'll allow you to create a jog very quickly. Right click, pick the bottom edge, and again you can show adding some more dimensions. And at this point we're done with the sheet metal part of the demonstration, so you can close this file. You don't need to save it. And you want to close and return back to the top level assembly so that you can see the sheet metal part in the context of the assembly. It looks very nice. And so at this point you're ready to move on to the next configuration.